We're going to evaluate this double integral. Notice that the limits of integration are numerical. That means that it's over a rectangular region where x's are between 0 and pi over 2 and y's are between 0 and 1. So we have this rectangular region here. It doesn't matter the order in which we do the integration in, but what was nice about this problem is that you were given this hint that it will be simpler if you were to switch instead of leaving it in the order that it's given in. Doing it y first turns out simpler. So we integrate from 0 to 1 first in y. Then after we're done with that, we'll integrate from 0 to pi over 2 in x. The integrand is x times the cosine of xy. And so the x is constant in terms of y. It's like integrating the cosine of 7x or 7y dy. Remember, there's the extra factor of 1/7 that comes out to undo the chain rule. Tell them to be quiet. Okay, so that's what we're going to have. We're going to have the x from here, and then 1 over x, the sine of xy. And so that's nice that the x's cancel out. We don't have to do integration by parts. And you end up with just the sine of xy from 0 to pi over 2. I'm sorry, evaluated from 0 to 1 would be the sine of 1x minus the sine of 0. And the sine of 0 is 0, so that's nice. And so we're just integrating the sine of x from 0 to pi over 2. What function has sine of x as its derivative? It's negative cosine of x. That's your antiderivative. Evaluated from 0 to pi over 2. Gives the opposite of the cosine of pi over 2, which is 0 anyway, minus the opposite of the cosine of 0. The cosine of 0 is 1, so ultimately the answer to the question is positive 1.